Hello everyone, I'm sure you're doing awesome. So now from this lecture onwards, we will gradually start going towards the true distributed architecture of the backend and the platform engineering. We are going to discuss about various patterns that we generally use in backend and whenever we want to bring multiple platforms together into our application, there these patterns will be very useful. So we will take an example and try to see what do we mean by bringing different platforms together. So suppose you have an application and your application in some way it receives multiple payment from different sources. Okay, so when I say different sources, like it can be a REST API. Through REST API, suppose some of the mobile application which is directly calling, like user is using this mobile app and calling our payment endpoint. There can be a Kafka topic. So suppose there is a lot of NEFT or other kind of the backend payment processing is going on, and which comes through the Kafka or the distributed any other distributed form of a queue. It can be like a Kafka from partners as NEFT payment suppose, and then again there can be some information for the consolidations, like consolidations at the end of the day when we do some sort of a back calculation to make some ledger connected in financial system. So those sort of things are being done by the CSV file in a SFTP server. Okay, so this sort of things are together needs to be baked into our single application where we are putting our payment backend all together. So what this ideally would do is, if we have to just name a few, it is going to validate everything. So a kind of a validation layer will be there, and then there will be a routing layer. So what routing layer will do is it might have to go through various process, right? Like some kind of a fraud check, some kind of a checking of whether the sufficient balance or not. So those kind of routing layer it has to decide, and then like the handle failures, or if we have to do any kind of retry, idempotency, duplicacy. Suppose a duplicate payment came across, how do we handle that? Sending notification across, like a event driven notifications across different systems. Suppose some systems are subscribing whether this payment is actually completed or not in form of a webhook, and on top of it, definitely we have to make the whole thing scalable. So now we are gradually getting into the further the advanced concepts of with this, from the back end to the platform to the system design, and from there we will go to the cloud architecture as well. Like all these things, suppose we want to use a certain cloud as our backend. So if I have to draw it out for better convenience, because we are just setting the tone for this whole lecture. So there is a REST request that would come to us. Just take the REST request case, like we will go into the rest of the things later. So a REST request comes, that REST request is going to validate the data. Okay, and after validation, what it is going to do is it is going to enrich or add the metadata. So for example, it can be it can be various steps, like you after validation, you know that it is connected with some sort of a different customer. So those sort of validation metadata you might need to add there, or you can even skip this set. After this, we are going to go into some sort of a router layer. So what router layer would do is it would take multiple decisions, like whether it is a debit card payment or it is a credit card payment or UPI. So suppose for the time being we are just considering UPI and credit card. Okay, and so from there it will again go to different processor of UPI payment processor, So it is going to call our UPI endpoint of NPCI, and the credit card is going to call the bank server directly. And from there, after having all these things, we are going to send a response back to our caller, like whoever called. In case it is a successful, we are just going to make a response to that person. Okay, so this pattern underneath will have multiple things, although we just did it like uh, with a single flowchart. To implement this sort of a thing in real life, we are going to need like Kafka streams. uh, there are things like AWS step functions or Azure durable functions. Um, and something like N service bus or Azure service bus. This sort of things we will definitely going to need for this kind of a multi-step processing. So throughout our journey, that what we are going to take for the next 10 15 in next 1 hour, we are going to learn all of this pattern. And so you will be very confidently able to design systems after this, to like how messages flow through backend. That is one of the great idea that you will get. And split, enriching of the data, and the transformation of the data, all these things will be taken care. And then building the fault tolerant one. For example, what would happen if there is a failure that we get into our transformation process. And also like how enterprise systems are, like large enterprise backend, how exactly they are being built. All these ideas you will be getting in case once you are able to understand these things. So before going further deep into this, I want to introduce you the very basic code generally we use for the integration flow, so that you get a heads up like what are the things we need to do. So in this code, the first thing that you see, there is a payment input channel that has been introduced. So this is the kind of a source, or this accept the messages from any input rests or Kafka file via a named channel. And before that, like if I have to start very organic, the bin is basically like when you annotate a method with bin. So Spring Boot creates a integration flow bin, and at startup, the Spring integration will parse it into the components like the channel, endpoints, handlers, and then write them together automatically. So think it as a kind of a pipeline definition that you are creating. So with the integration flow that we have over here, this is basically this particular integration flow that we are talking about. This is the entry point, or this is going to it is like the fluent builder that lets you describe that where the messages come from with the things like from, filter. So this gives you the whole interface to the entry. Okay, that from where it is going to come, all this from, filter, transform, route, everything is part of this integration flow. So you see we are returning a integration flow, and we are gradually building all the logic over here. And then when we are talking about this from, this is the kind of the actual entry gate that we just discussed earlier. So when I say entry gate, it means a channel is like for that we need to understand what a channel is. A channel is a pipe that carries the message object. Okay, so it is going to carry a certain message objects, and the payload and the header, everything will come from this particular input channel. And why we are mentioning here the filter is basically the validation. A filter decides that whether the message continues or stop. Like it generally extract the payload and call some sort of a validation function. So those things will be called over there. If this validation fails, then we are going to fail it completely. And why this particular thing matter architecturally is, there is a like without this you have to repeat your validation logic everywhere, like in your REST controller, in your Kafka consumer. So here, the moment you put a validation like this, what you can do is uh, you will be able to make sure that your validation will always go through this guy for the filtration purpose. We will definitely discuss the transform and the router related information as well. But before that, one thing I again want to make clear to you like this about the entry gate, that it can be, for example, for the payment input channel, there can be one flow. For the payment CSV channel, okay, so you are putting some kind of a consolidation across and there is a CSV channel. From payment CSV channel, there will be another flow. So in that way, there will be multiple flows in this process. And why this thing important is, now we are able to segregate all of our channels into these different integration flows. After that, there comes the transform. So transform is going to enrich the metadata. So when I say enrich, like it might need a transaction ID, or it might need to add some sort of a logging. So this is basically like add logging, or add some kind of a transaction ID as a unique ID, or some idempotency key you want to add to make sure that same request two times it doesn't really get processed. It also might add like the timestamp sort of a details. And then why the transform is before routing we are doing, because the routing often depends on this metadata. So based on this transaction ID, the routing can have its own engine, or suppose there is a certain risk score we are going to add through transform. Like in the transform, we are putting our fraud detection check. So based on that fraud score, our route is going to be probably go into the discard channel. Okay, here we have mentioned two channels of Stripe and PayPal. So alongside that, suppose there is a discard channel as well. So that is why this this transformation is very much required before the routing. And in the routing, as you can just guess, that it is a content based router pattern. What it is going to do is, it is going to extract the routing key. So it can be, for example, if it is card related details, then it is going to put the data into the card channel, and for the Stripe channel. And if it is PayPal related details, then it will go to the PayPal channel. So this is on a very high level how a integration flow look like. And definitely we are going to explain to you that how exactly this integration flow will come into the main execution flow. But right now I just wanted you to have all this idea, like from where it is coming and where it is going, and in between the filter transform, what are the exact thing that we are doing. Okay, so now let's talk about the whole flow uh, in terms of a mental model. So we are going to create a very basic uh, flow chart. So there is a any source. This any source, like when I say any source, it means like it can be REST, Kafka, or email, or some kind of a FTP source where the CSV files are there. So from there, it will come to the payment input channel. Like it will say that, okay, I have some payment input for you. From there, it will go to the filtration. So filtration would do the is valid logic. Okay. So this is the filter or the gatekeeper. And from there, it is going to go to the transformer. So what transformer would do is, it is going to add transformer. It is going to add things like timestamp, the fraud score, and n number of metadata it might add. After that, it would go to my router. So router is going to define based on the type where it will take, like the card, crypto, UPI. Based on all these details, it is going to route it to the proper channel. And over here, the key insight that I want you to get it as a takeaway. So this is not a method call chain. Okay, so this is a very important thing to understand, not a method call chain, rather it's a declarative blueprint. And the Spring integration materializes this flow at a startup, and channel becomes beans and router becomes the subscribers, and message flow automatically gets into here when published to payment input channel. Now, suppose let's take this example. So suppose there is a crypto payment has come through in a Coinbase channel, but you haven't defined any Coinbase channel yet as your integration flow, then what would happen? So it is going to throw a simple message delivery exception. Now, how integration flow is actually gets called. Okay, so this is the kind of a flow, and what if this particular channel is not defined, the entry gate is not defined, that also we have mentioned over here. Or suppose there is a certain channel mapping being done, that channel is not defined, what will happen? That we discussed over here, that the Coinbase channel is not there, so it will go into the message delivery exception. This is now we need to understand how integration flow actually gets called. So right now what we are doing is, we know that in this way we could create a bean, and that bean will be registered as a component, and blah blah. But how in my program I'll be able to use this powerful pattern? So if if we are thinking that it is directly going to get called from the payment controller or some sort of a post, then it is not a correct mental model. Okay, so let's look into what is not correct at first, then we will build how it is actually being incorporated into the production. So in case you are thinking that in your payment controller, you are going to just inject the flow as a payment flow, and then further this payment flow dot execute you are going to do. So this is not a correct way to do it. This is how the actual code flow looks like. So you are going to have a messaging gateway. So this gateway is going to have your payment input channel, and using this gateway from here through our REST controller, we are going to make that call. So here we are going to auto wire our gateway, and this particular integration flow which we are writing over there, you can see there is a default request channel. It would automatically connect to this particular payment flow. So this will be in our blueprint and it will be executed automatically. So what exactly happens behind the scene is, the REST controller that we have, it is going to create a message. Okay, nothing else. It is just going to create a message, and it is going to send it to the messaging gateway. Okay, and this messaging gateway is going to do something like send to payment flow, or payment flow, like the way we wrote over here. Okay, here we have written only process. So suppose it will have this send to payment flow. Now this send to payment flow is going to directly publish into our uh, the channel that we have mentioned earlier. So here we have mentioned that the default channel is this one, right? So it is going to publish into the channel of payment input channel, and from payment input channel, then it is going to find this exact integration flow that we were just earlier talking about. So this guy, um, that we just discussed, this integration flow will be called from here. So the moment we are getting from this payment input channel, and then the result arrive in the output channel, the response returned to the controller via the gateway. So this gateway is the key. The gateway that we created, it is the key, and definitely we will go more deep into the gateway, but we are gradually building our intuition towards what exactly this message driven architecture is. Now, if you have followed till this point, two obvious question would come to your mind after seeing this code about the gateway. That who implement this gateway method and how does gateway know where to send the message, right? So it seems like we have written this gateway here, the payment gateway, and we are auto varying this payment gateway, and magically somehow it knows that it is going to send it to this particular bean. But what exactly happens behind the scene? So who implement the payment gateway process? So this is the first thing that we have, this gateway process. So who implements that? This is our first question, right? Like I will write it so it is more clear. Who implements payment gateway dot process that we have as our interface over here? Okay, payment gateway process. So the answer, like the short answer is the Spring integration implements it for you at runtime by generating a proxy. Okay, so this is very important. Like Spring generates it for you as proxy, and when it does during the runtime. So what really happens is when Spring Boot starts, it scans for the message gateway interfaces. So all the message gateway interfaces that will be there, so it is going to search for that. So let me write it very clearly so that it get stuck in your mind. This when during Spring Boot startup, it scans for all the at the rate messaging gateway interface. Okay, so this is the first thing that happens. Then the Spring integration creates the runtime proxy. So what this runtime proxies do? It is just a dynamic implementation that is going to get used later. Okay, creates the runtime proxy for the interface, and then that proxy becomes the bin. So this whole thing happens behind the scene. Okay, this proxy becomes the bean that gets injected into controller when we are doing this auto varying. So we did this auto varying over here, right? In this part. So this is where exactly it get injected into the container. So like your interface has no concrete class around the application code base. It is a runtime setup. So this is the whole outcome. So this particular interface has no concrete class and it is a complete runtime setup. Okay, now the conceptual pseudocode of what the Spring generates would look something like uh, there probably will be a simple method, and that method will be called by the actual implementation during the runtime. Now let's come to the second part, that how does the gateway know where to send the message? And this is a very important mental model, guys. The gateway never sends to a handler directly. It sends to a channel. Okay, so this is the primary thing. It never sends to a handler directly. Rather, it sends to channel. Why I am writing this? Because these are the core concepts that we must grab. And when you go to this particular channel, the channel delivers to whoever is subscribed next in the flow. And there are two separate questions hidden inside this whom. Like which channel does the gateway send to? So it is coming from the default request channel, or like you have some kind of a method override. So for example, here we have a method override of the messaging gateway, right? So here we have defined that what is going to be my default request channel, or what is going to be my if I am overriding it, what is going to be the other channel. So this particular line that we wrote earlier, okay, so this ideally means like all methods sent to this payment input channel It is going to be the default one unless overridden. So unless anybody is overriding me, you please send all of them into this channel. And how does the message reach this write processor after that? So once you are putting into the payment input channel, it is the responsibility of the integration flow after that. Okay. Now, this is how the default channel can be overridden. So, for example, under our messaging gateway, suppose we have this string pay, okay, and we haven't mentioned anything on top of the on top of that method. In that case, it is going to be the default one, as you can say. So, the default will be this one, okay, and here we have specified our request channel. So, what would happen is in this case, like we are going to have the refund input channel into this refund. So this is how like the gateway gets to know where it should be actually sending its response into. And of course, we should mention that there will be two integration flow, like one that we just mentioned about the refund input channel. The other one is the payment input channel. There will be different flows, and based on this information, it is going to go to either payment or the refund or whatever the one that we are writing. So as this is a very important concept, we are just mentioning this gateway again, that if it is a default or whether it is a default or a override, we are going to send the messages like this through the messaging gateway. It will come to the actual payment gateway, and it will have two methods of pay and the refund, and the controller is going to call the request one, and here the controller is going to sorry, the payment one, and here the controller will call the refund one based on whatever the channel that we will be having. And as we said, like in the code, we are if we are mentioning for the refund, it would go to the refund channel. If we are going for the payment, it would go to payment. If we are not mentioning anything, it would by default come to payment. So the payment controller generally looks like this, that there is a gateway pay or refund, and based on that, it is going to come to the payment or the refund that we have mentioned. So now let's discuss some question to understand our stand, so that we could see through the real life scenario and apply integration flow there. So let's take this question over here. Your payment system now requests three sources. Okay, REST API. It is also getting some kind of a message driven Kafka, and the SFTP files like the batch in every hour, some sort of a CSV that is coming. So how would you design the integration without duplicating the validation and the routing logic? So let's see how our code would look like. So before going to the code, let's understand why this situation is some way tricky. It is tricky because there is a particular element of REST API that needs immediate response, and then there is Kafka. Kafka is going to need the event-driven syncing, and then there comes the SFTP files. Like there is a batch, and you have to poll it every single time. So in a principle, what we are going to do is we have these three sources, and we are going to converge them so that we do not duplicate any logic, or we could come to a singular process like validation, routing, or pre-processing. All these things we have to do in a common place. So the approach would be somewhat like this. So here we are going to have our REST, and we have to have our Kafka, and also we have to have our SFTP. Okay. Now all of this guy would go through their own adapters. So REST is going to have its own REST input channel. Kafka is going to have its own Kafka adapter, which is kind of a message driven. So I'm just saving some typing and writing it as a KA. That means Kafka adapter. And then also our SFTP is going to have a file adapter. Okay. So all these things, they would come to common place where we are going to have a convergence through our common payment channel. And this common payment channel, what it will have underneath is the common payment flow, the filtration, the routing, which are the common things. So all this all the specific ones are being taken care by this input channels or the adapters, and whatever the common logic, that will be taken care in this common payment channel. Now let's go into the code in a step-by-step manner. So at first, what it does is this guy listens to the flow of a REST input channel, and whatever the message arrives there, it forwards it to the common payment channel. So this is quite clear, right? Like from here it gets forwarded here. So we are not putting any kind of validation or anything else here, because the moment we put validation, it might there might be a chance of duplicacy. So we want to create only source specific logic over here. So rest to be just a producer. Okay, any kind of consumer logic we are going to put into our rest input channel. Okay, so when we are going into this REST input channel, like couple of more points I want to say, that usually it is generally a HTTP inbound gateway, or like the Spring integration HTTP sort of a thing that we design. Now comes to the Kafka entry flow for the Kafka adapter, this one. So here what is happening is the Kafka message driven channel adapter is an inbound adapter. It's subscribed to a topic, and each consumed record becomes the Spring integration message. From here you can see this is the key part. We are having an adapter, and then we flow it towards our common payment channel as we discussed earlier. And why this is again powerful, because this is configurable. The moment I want any sort of change in my common payment channel or our integration flow, if it is come from a different Kafka topic, we will just change in our adapter, that's all. So the interesting thing to note over here is we are going to have a e-polar. Okay, so this e-polar, what it is going to do is this e-polar guy is going to check for every hour that whether any file it could find at its designated place or not. If it finds any file, it is going to take it. There is some processing it will do and send it to the channel. So all the things you see, it is kind of becoming kind of a common pattern. And at last, there is the single shared flow, or the one truth. So this part that we are talking about, this is nothing but a singular truth. So this singular truth is going to take the integration flow from the common payment channel, and then over here we are going to put all the things that we want to do, for example this filter, route, and whatnot. Okay, so through this routing we are going to have this determined type, as you see, like if it is card or crypto or UPI, based on this type we are going to route it to further channel. And what exactly happens in the runtime for the REST case? Let's take one single case and it will give us complete idea. A REST request arrives. Okay. At first, we are going to get the REST request. The controller or the inbound gateway sends the message to the REST input channel. So once the REST request arrives, it takes it to the REST input channel, as you can see th through this. From REST input channel, the REST API flow forwarded to this REST API flow that we have written. It then forwarded to the common payment channel. And once the common payment channel over here runs the validation and routing, and then it is getting routed into the proper, based on our type, it is going to go into like our actual common payment. So from here, it is going to get routed, and after routing, the flow is going to produce a response and the reply will go back. So here it will have the route, and route will then just generate the response over here. Okay, then the response will go through the same path to the party where it came from. So two things can happen here. The controller, as we have earlier seen, calls the gateway process request, and the gateway proxy convert the message and send it to the configure channel. And anyway, like we will come into the details of the message in a few seconds, but just understand these things. This nobody is putting magically the data into the REST input channel, but the gateway process that we wrote earlier. Okay, so over here we are going to do some sort of a gateway process, and this pay behind the scene probably will take you to that particular channel of the REST input. Okay, or else what you can do is you can write your own controller. You can define a inbound HTTP endpoints. The HTTP endpoint gateway acts as a producer, and your session will include that like your and through your API session you are going to send it to our actual REST input endpoint. So the code there would look something like this. Okay, so this is very important to understand that it is not a magic, like nobody is going to put the REST input channel like a magic. So we have to define this inbound gateway somewhere so that this whole process is being completely smoothen up. The next question is like, how do we know the REST input channel is done? Let's understand it very deeply. How do we know the REST input channel is done? And now it is time for the common payment channel. So the particular mental model that we should develop here is a channel is not a step, okay? Rather, it's a pipe. It is a pipe which is connected to one after another. And the done is simply the message successfully delivered to the next hop. So when we have our flow, our flow defines something like this, right? Like the bin that we defined earlier is like this. So this actually means the REST API flow is subscribed to REST input channel as a consumer, and whenever a message arrives, the flow immediately forwards it to the common payment channel. So this guy is, again, I'm just writing it for further clarification, is subscriber to REST input channel. Okay. And whenever a message arrives, the flow is going to forward. The flow is going to forward to the common payment channel. Okay. So the REST ingress is done, the message, the moment the REST ingress done, the message is forwarded. No timer, no state machine, and no extra signal is needed. So what exactly happens there? Like we have a HTTP thread running into that channel. REST input channel is going to send the message to a direct channel. I will just draw it out for you for further clarification. So this whole thing runs in a thread. A thread is going to send the message to our REST input channel, and from the REST input channel, we are going to get it forwarded to the common payment channel. So the moment the this channel dispatches something, the common payment channel receives that. So let's understand what is messages. Message is from first principle, it is just an immutable data structure with two parts. The first is a payload and second is a get header. I understand that you are probably not getting anything where it is used or how it is will be useful in our case, but let's take it from a example perspective. So to build our intuition, just think through. You have Netflix or Google. uh, Netflix payment. Okay, I think that could be a good example. Netflix payments you have to build in a global scale. So the moment you are going into the global scale, there are so many things will come, right? Like the risk score, the fraud detection, the geo check, if it is India, the KYC sort of a thing, and also information like routing will be very important there. So everything must happen fast, accurately, and in a async manner. Like the risk scoring will be happening at one point of time, the KYC validation can go ahead completely parallelly in a asynchronous way. So such companies never pass around the raw Java object or the REST DTO. So this is the key thing you need to understand, that these companies, like, they don't pass raw Java objects. Okay. Or also DTO you can think of like the data transfer object. So what rather they do is they take the messages. So message is basically kind of a envelope plus package. So what will be in that envelope and package? We have to understand the envelope as our payload. Okay. The envelope is the payload, and on the other side, the package that we have, the package is basically the headers. So headers do have like a metadata for routing, priority, and we will see it in our example. So payload is, again, it is basically the actual item in a real life analogy inside your box, and the headers are nothing but, you could think like a labels. For example, if you are passing a Amazon parcel delivery, payload means it is whatever is inside that parcel box, and headers means the stuff that are as labels or tracking ID, the priority flag, the source warehouse, those sort of details. Now the message payload or the data, how does it look like? So we are gradually building our intuition on one section. So message payload can be things like payment request, fraud check request, KYC verifier. These things will go under the payload, and this can be built in a this basic way. Like, we are going to create a message object, and through the message builder we will just say that this is going to be our payment payload. So all the payment related information will be built into this payment object that we are seeing over here, but it will be converted into a message. So this particular message interface that we saw earlier. And our headers do have this many number of things like the correlation ID, sequence number, sequence size, the priority, timestamp, source, etc., etc., etc. So it tracks the request across 20 microservices. So here it is going to be the trace ID of Uber's fraud, the sequence number, the batch item. All this information generally goes under the header. So if I have to take a complete code, how how full message looks like, the message looks like somewhat like this, that there is a payload of payment, and alongside that there is multiple headers. So headers are very important, like for any kind of information that we need for a to take the decision for a certain message what we will do over the time. So this message channel that we are talking about, this is the pipe. Okay. So what exactly a message channel is? Message channel is the pipe where the message moves, and this guy is responsible for moving our message around. So for example, we generally have things like direct channel, queue channel, which we will come over the time. So using those channels, we are going to dispatch the messages from one part to another. So let's understand with code flow. Okay. So here, look, we are defining different message channels. So one is the payment input channel, message channel, and then we have the Stripe channel, and then we have the PayPal channel and the crypto channel. So whenever we are getting something, we are returning the direct channel. We will come into about things, these things. What is a direct channel? What is a queue channel is? But right now, just think that this is going to just sync the dispatch for simple for the demo. Now we have this particular flow defined, that in case you are getting something into the payment input channel, you can take it to the Stripe, PayPal or crypto. All these channels we have mentioned over there. Now the moment something goes to this channel, so this understanding this relationship is important. This Stripe channel, the moment something is going to this Stripe channel, what we are going to do is we are going to trigger our integration flow, and this integration flow will take it to the handler. And as you can see, like this handler is again over here, we are doing a very demo sort of a operation, but here will be a lot of business logic and lot of flow required in this particular integration flow. Now coming to the other parts, like how this guy is going to get run in a normal demo scenario. How this guy is going to get run is, we are going to show it via this demo runner. So this demo runner is going to have this payment input channel, and this payment input channel that you see over here is going to send this particular message that we are building over there. So this is a payment request. So payment request is nothing but like a simple record sort of a thing, like it would look like a simple domain record. I will just write it for you on the other side. So payment request is nothing but like this. So we are going to build this message on this payment request with my payment object, and set some of the header. And the moment I am getting it into the payment input channel, uh, I'm going to dispatch it into my payment input channel. And then what the flow will be, let's again go at the top. This integration flow will be triggering, and this whole thing will then go step by step. So a better way to think about the channels is like they are not just pipes, rather they are the traffic control system of your messages. So let's talk about what are the different kind of pipes we have at our disposal. So the first thing is of course the direct channel, and let's take the example of the Amazon Prime order validation. So it is a same thread execution that runs through it. So the bean, generally we define something like this for a order validation direct channel that we have. So why Amazon uses it is the prime order requires a transactional integrity, like a validation plus fraud check plus inventory lock, all the details it might need, right? Like in terms of, I will just write it there, the validation, fraud, risk, geo check, inventory, many thing it runs. Okay, so failure at any step, the entire order is rejected immediately with no partial state. So same thread, it is like a spring transactional propagates correctly across this flow. So uh, that is why we call it a direct channel. So when we have like this kind of a REST request response going on, or the transactional boundaries are going on, synchronous validation, like when we have to do actual synchronous operation. Okay, at that point of time, the direct channels are useful. So if I just have to write a minimal code for this, it would be like we can just create a bean with our message channel as we have created earlier. But here we have created a payment channel. It will be this, it will be syncing in the same thread, and the moment you are putting it into the payment channel, this handler will kick in. Then there are publish subscribe channel is there. So what exactly is a publish subscribe channel that we are talking about? We know like we can broadcast to many receivers. That is a very important step here, right? Broadcast towards the many receivers. Sorry, many subscribers. Subscribers is the correct term to use here. So a great example for this is this payment success sort of a method. So the moment you pay something in your Amazon, you will see that there is some kind of a uh, order will be created. There will be one email notification, there will be one WhatsApp notification and whatnot. Everything is being created. Also behind the scene, the inventory is being sent a notification or observable information. So from the big tech scenario, like all the details like the email service, analytics, fraud system, everything, they can run asynchronously. Like they do not have any order like we had to do over here, like the validation, then fraud, then risk, geocheck. Anything that fails, we are going to fail the whole thing, right? Like if anything fails during our direct channel over here, it is completely separate. All can run in parallel. So it has no sequential, it doesn't require any kind of sequential sort of event execution. So when to use this publish subscribe, like when we have this fan out notification sort of a thing, this event driven microservices, everywhere we generally use this pub sub models only, and the code again would look somewhat like this. So there is this two channel we have, right? One is for the success, which is going to be a sync broadcast, and then there is again the publisher subscriber. So if the integration flow listens to this async success channel, it is going to mark it as a publish subscriber. And the moment we mark it as a publish subscribe, what is the difference between this handler, this direct channel handler, and this is, it is going to do all of these things with through a parallel execution. Now the next thing comes is the queue channel. Queue channel is again a very interesting one. So it creates the FIFO plus the back pressure. So just according to the documentation, if we go, QueueChannel does like a asynchronous buffer or a FIFO sort of a uh, mechanism that it introduces for high throughput, rate limiting, and async processing. So, um, like you have this Amazon order use case. Let's take this Amazon order only, like as we'll be able to connect what we have been doing earlier. So, order events are coming. Suppose during like a Republic Day sale or any other festive Amazon festive day sales that is going on. Then the worker process them at control speed. So what we need to do is we must buffer. So in this case, like when this this kind of events are going on for Amazon, this buffering is kind of a mandatory thing, and it must not drop any messages, and we need to keep on retry and have the stable throughput around. So in that case we need to use the queue channel. Like when we know there can be high load spikes, there can be batch processing, like one process can take more time than the other. So in that case we are going to use queue channel. And so if you have worked on like the SQS or Azure Service Bus or RabbitMQ and anything out in the blue in terms of a queuing architecture, this thing is quite similar to that. So what queue channel does is queue channel is going to buffer this 500 messages, and over the time through the polar we are going to send the messages this. So what it code essentially is, it is just an in-memory FIFO queue with a 5000 message capacity. And when we are having this send, the send is going to send the messages to our queue, and the messages persist until it is being consumed. Like unlike direct channel, when it will get drop if there is no subscriber. But here the magic behind the scene is like the messages persist until consumed. Okay, so it is not like the direct channel. And the one of the technical analogy we can take, suppose the Uber's ride requests are coming in a very huge manner in the New Year's Eve. Okay, like all the people are after the 31st night party, going they are going towards their home in Uber, and this much amount of request to handle it, Uber could use this queue channel, and this polar which we have written over there, that is the actual worker. So this service activator is basically registering this method as a message consumer. It is telling that I'm going to consume the message, and the polar is configures the background thread that checks the queue every 1 second, that whether messages are coming there or not. And the default behavior is one message per poll, and we can keep on changing it with the different configuration like the throughput. And another one important uh, channel type is a priority channel. So for the priority channel, it is like some events must be processed before everything else. Like whenever a transaction is going on, suppose beyond a limit, then the first thing it has to run is the high risk fraud alerts. It has to send to the user on that very moment the banking transaction starts, right? So in that case, we have to use the priority system. So all the things that we learned so far, like the messaging gateway, uh, the controller that calls the gateway, integration flow, and the handler. There are many things we understood, right? The messages. So we are going to bring all of them together now through a code example so that we are totally clear whatever we have learned till this point. So this is going to be our the entry point of the application. And one important thing that I want to point out to you is this integration component scan. So this is going to find the messaging gateway interfaces. Okay, and why this matters, because Spring need to find your messaging gateway and create the proxy bean at the startup. Then we are going to have our payment gateway interface. So in this interface, we have two things, like a process payment, which is going to uh, response the payment, the actual payment response, and there will be a fire and forget sort of a mechanism. And the question is, who implements this method? If you may ask, like we already discussed it, but still it is important to understand. Spring integration generates a proxy at a runtime. And how does it know where to send? So it knows through that if you are mentioning any default any default channel there, rather like not mentioning any channel there, then it will fall back to the default request channel, that is the payment input and the payment reply channel. Okay, so how does it know where to send? The default request channel will tell that send it to the payment input channel. And how does it know where the replies will go? It would know again from this reply channel. So two channels are there. So next comes the integration config. So here we are going to mention that what kind of a channel it is. Like for example, here it is going to be a queue channel, and from where it is going to get its information from, and where it is going to route, like it is going to send handler output, whatever the handler output it will get through this service, through this payment service, it is going to send it to this particular reply channel. So the key points over here again is the from. It means the flow is subscribed to this channel at the startup. So at the startup only, anything that comes into the payment input channel, we are going to forward it to this integration flow. And for request reply, the handler must produce a reply. Otherwise, the gateway will time out over here. So this handler, as you can see, it is going to send the payment service. And how the payment service looks? Like this. So in the payment service, we are in case the gateway expects a response, this must return that particular response payload. And just pretend all the validation and the processing is happening over there. Like why I took this minimal code is so that I can actually tell you what happens behind the scene. So this guy over here, this service is going to return this particular payment response, and it is going to go through this particular channel of payment reply channel that we have mentioned earlier. And this whole flow will be triggered via this post controllers that we have for the post mapping of pay and the submit. And as you can see over there, like we already have this post process payment and submit, and gateway is going to pick it up. So the first one is going to call the proxy, and I'm not going to create any other flow over here. It is just going to take my default request to the payment input channel. Anyway, let's have a complete end-to-end explanation what we had so far. So at first, the Spring Boot starts, it finds the payment gateway via the integration component scan that we did, right? Then it creates the proxy for that. So once this is done, a proxy is being created. So proxy is created and it calls your bean payment flow that we have written earlier over here. So and how this proxy will be connected, definitely through this process input channel. Now from here, please understand during runtime what would happen. In the runtime, the client will call this pay or this post that will come, and controller will go to the gateway process payment. The proxy which got generated, it is going to intercept the call. It will convert like the arguments into message and all, sets the reply info, and then sends it into that payment input channel that we wrote earlier. And then the subscriber would take the flow as a consumer, and it is going to consume the message and calls the payment service dot process. But because this is a super important flow, so still I'm going to create a end-to-end diagram so that you understand what every part is doing over here. So at first, from the client, a request would come. Suppose the request comes in form of the post of the payment request. So from the client, the request would come to the payment processor, okay, or rather payment controller. So it comes to the payment controller, and what payment controller does is it is going to take this post request. I will just write it over there. So this post slash post request that we are going to have in our pay endpoint, it is going to take it to the payment gateway. So now this payment gateway is basically the proxy that got created earlier. Okay. So this is the payment gateway, and this is going to be the proxy. And this proxy is further going to take this process payment request, and then it will send it to the process input channel. So it took that process payment request, right? Like the code that we wrote, this gateway is going to take the process payment request, and then the process payment request is going to take it to the payment input channel. So the next one is going to be my payment input channel. So this payment input channel, how it is going to get the message is completely through the proxy. Okay, so everything is being done by the generated proxy, and after that it will go to the payment flow. As you know, the payment flow does the complete dispatch to the it processes the request, and then it dispatches the request to the reply channel. So and from there, like once we are dispatching it to subscriber, then further it will be taken to the, after the processing, it will be taken to the input channels, sorry, the reply channels. Input channels are already being taken care. So this is the main flow or the mental model that we all of us should have clear in our mind, that what goes behind the scene, what is the role of a proxy, who creates the message, and how the messages are being sent. But one thing that might come to your mind is, what is the role of the message in that example? So even though we have never built the actual message builder in our controller, the Spring integration still wraps the payment request into a message come payment request behind the scene when you call the gateway method. So message is the simple transport envelope, right? Like what we discussed earlier. So message has two components there, like the payload and the header. So where exactly the message created, if you ask me, then the message is being created in this particular part where we are returning the gateway process payment, right? So during our post call, yes, we are creating the gateway process payment over here. So what really happens is, the Spring generated a proxy that implements the interface on invocation, and it behind the scene it roughly creates a message from that method args, and it creates the important headers like the id, timestamp, and maybe the reply channel, the other information also as well comes there. So in case you just debug through it, you will find that this a message has been created there. And again, why do we need message at all? Because if we passed only the raw object between the steps, we would lose all the control plane metadata that is required for the messaging pipeline. So that is why the payload plus the header, both of the things are very important here. And of course, the observability, tracing, those kind of things also, it helps a lot. So in case of our like in our code base, when we are talking about the messages now, this is the part where the messages are being created. Now again, we are going to take care of a very important concept called the Java domain specific language, or the Java DSL section. We are going to take a like rather directly jumping onto the definition and all. We are going to mirror this concept through a uh, like a use case scenario. And let's start with the Netflix payment that we have been payment platform that we have been discussing. So the Netflix payment would come from various sections, right? Like the web, mobile, it can be the third party merchant API side, and they all must flow through all the things like earlier we discussed, the validation, the fraud scoring, the enrichment, and whatnot. So Java DSL let us express all of these steps in a given pipeline. So what exactly happened in the whole thing? Like we already discussed a few things about the DSL, although I didn't coin this term because I didn't want to confuse you with uh, with the increasing number of jargon. So at first, what we have is the flow entry point, or the guy who defines that this is where the program starts. Okay, so here we had different sort of a entry point we can have, like the bean channel, the supplier inbound source, it can be multiple. So those detailing I am not exactly going on. So after that, what happens is it goes through the transformation. So transformation is again a very interesting part. So it turned one form of data to another. So suppose the Netflix call have to call the internal fraud service, fraud scoring service, and it has to add the metadata. Okay. So after calling the fraud scoring, it has to add the metadata that has to go through the transformation process. So the code generally look for the transform is something like this. Like we will have a fraud score, and we are going to have a enrich payment with that particular fraud score that we got there. Then uh, we are going to take care of the routing. So in routing, what happens is like the Stripe handles the card, and the Coinbase handles the crypto. And again, like this code we already discussed, but still, if I have to just put a minimal code for your understanding, the route looks like this. Like in case it is a card, you go to the Stripe channel. If in case it is a crypto, you go to the crypto channel. So routing is externalized from the business logic, and it is completely separated here. Then there comes the steps like filter. So filter basically validates, or it has any unusual events. It can filter that particular or rather the discard is the correct term. Like it can discard those particular terms. So filtering is over here is validate and discards the bad events. And from there, again, if I have to just introduce how filter looks like, in case there is a amount related issue, we can just put it into the rejected payment channel. Again, after this there comes handlers. So in the handlers, where the business logic actually get executed. Now that we have gone through all the channels and everything, we are going to call the Stripes or the Coinbase, all the API that we have over here in this particular section. So handling or the dot handle, this section is meant for our business logic. Okay, and again the code is kind of look like this. Here we are going to return null and end the flow in this part. In case we do not want to do anything, we can just return null, or we can have a separate service in place and we can just write something like this handle stripe service. So there is a further, if we have to take it to any specialized channel, we can just bridge it through this dot channel, and whatever the channel that has been registered through our gateway and our the configuration, our bin configurations and the integration configuration, it will take gradually to that particular channel. So now let's build the complete DSL here. So here we have the entry point of the payment input channel. Then we are going to do the filtration. After filtration, we are going to do the transformation, and then further we are going to route based on the payment type. This is something that we are doing. And if we have to talk about like how does this Stripe, PayPal, or the crypto flow that we have been talking about, how they look like, they look very generic in nature because we are just going through minimal code, right? So this integration flow or the Stripe flow that we have created over there as a Stripe channel, like the moment it gets the Stripe channel, it then goes to the Stripe handle, and it is going to charge your information. So the very interesting part in this whole thing, probably you noted that the Java DSL make it look like the payments, like payment, we have been concentrating on payment, right? So in the payment it looks like messages are moving from through a pipeline from one step to another, like the validate, transform, route, handle, all these things. Okay, so each step is a method call in a flow, and this makes the complex architecture way more readable, testable, and scalable in nature. And so guys, that's the video. Like we have covered the Java integration in super detail, and of course there are some other very important details as well in the flow, but all the overall concepts like the DSL, the messages, how exactly the whole scanning is being done, how exactly your integration component scan comes to your program runtime, everything we have gone into real detail with lot of examples. So in case you have any question, please put it into the comment section. I will try my level best to answer it. And in our further videos, we will come back with things like the reactive, web flux, actuator, and then we are going to conclude our actual Spring Boot series and go into the microservices section.